Greetings, math fans. All right, today we're going to work on trig equations. Okay, and actually what we're going to do is we're going to be solving them. So let's kind of just start out with a nice little friendly problem here, and these are going to be, the first few problems are going to be called, they're linear. Okay, we have 2 cosine of theta is equal to 1. All right, when you're solving these equations, math fans, what you're doing, the first thing you want to do is you want to solve for the trig function. Okay, so in this case I'm solving for cosine, so I can divide both sides by 2, and I get cosine of theta is equal to 1/2. Now the question you're going to ask yourselves is, the cosine of what is 1/2? All right, and you're going to say, oh well, the cosine of pi over 3. So don't you guys agree? My answer is pi over 3. Now, some of you guys are saying, well, is this something like we just kind of worked on the arc and the inverse tangent, inverse, cosine, inverse trig functions. This kind of has something to do with it, but we don't have to worry about being in the range. All right, the reason we don't have to worry about being in the range is because we're literally saying, hey, the cosine of what value gives you 1/2. Okay, we're not saying the inverse cosine of something. All right, so, but it's kind of interesting. Don't you guys agree that cosine is positive here and it's also positive here? So really, if this one is my pi over 3, what is this angle right here? Well, isn't just 2 pi minus pi over 3, isn't that going to be 5 pi over 3? Right? Because there are always two answers for that, right? For positive 1/2. Okay, so we have two answers, but actually, can't you even add 2 pi to that, do coterminal, and that would be 7 pi over 3? And add 2 pi to that, that would be 11 pi over 3? And then can't you even add, can you keep adding? So another 2 pi, and it's going to be, so it's going to be 13 pi over 3. So in other words, I'm doing, I keep adding it on more and more and more and more and more, right? So aren't there an infinite number of answers? So this is the deal, math fans. What I'm going to do is I'm going to tell you there's a domain. I'm going to restrict the domain. Okay, I'm just going to restrict the domain just to give me a specific number of answers. Okay, I'm not restricting it like I did restricting the range before because I had to be a function. This is definitely still a function, but it's an infinite number of answers. Okay, if I don't restrict the domain. So for the most part, I'm going to restrict the domain to be between 0 and 2 pi. And notice this is a bracket, so that includes 0. And it's a parenthesis, so it excludes 2 pi. Very important. All right, so truly my answer for this problem, math fans, is theta is equal to pi over 3 and 5 pi over 3. So really, for these problems here, where cosine is equal to 1/2, there's two answers. Okay? All right, it's pretty interesting. Let's do another linear problem. I have -2 tangent of theta minus 1 equals 1. Okay, well I'm going to solve for tangent of theta, so I can add 1 to both sides. I get -2 tangent of theta is equal to 2, and I'm going to divide by -2. So tangent of theta is equal to -1. And then what you're going to say, so basically the way you do these problems here, so let's kind of, I know I did a few things before with cosine there, but basically what I'm doing is I'm saying, I'm looking at, first of all, the 1, and I'm saying, what's my reference angle? So my reference angle, again, I don't care about the negative for now, but I'm saying the reference angle is tangent of what is 1? Well, isn't it pi over 4? And we're doing everything in terms of radians here now. I mean, maybe we'll get some problems with degrees, but for now we're just going to stick with radians. So my reference angle is pi over 4, and then you're going to say to yourself, oh, okay, where is tangent negative? Well, it's negative here and here. So you're going to say, oh, well, isn't that pi minus pi over 4? And this one's 2 pi minus pi over 4. So that gives me 3 pi over 4 as an answer, and 7 pi over 4. And those are my two answers, math fans. Okay? And remember, if we're talking let's just kind of review the quadrants here, right? In this quadrant, of course, that's just a reference angle. In this quadrant, you're going to say pi minus your reference angle. And in this quadrant, you're going to say pi plus your reference angle. And in this quadrant, you're going to say 2 pi minus your reference angle. Those are important, and we learned those back a long time ago. If once you have a reference angle, it's pretty easy to figure out where what the answers are for all 4 of those quadrants. All right, but again, notice we got 2 answers for this problem. All right, so and of course, even though I didn't write it down there, for all our problems, this is going to be between 0 and 2 pi. Okay, and that's how we get our 2 answers: 3 pi over 4 and 7 pi over 4. All right. Let's try a quadratic. So we're going to have 4 sine squared of x equals 1. Okay, well, let's solve for sine squared of x. Divide by 4. So sine squared of x equals 1/4. And then take the square root of both sides, so I get sine of x equals 1/2. Oops, 1/2. Okay, you guys agree with that? Boo! What's wrong? Do not forget the plus or minus. That is huge. That is so huge. So do you guys agree I have sine of x equals 1/2? And I have sine of x equals negative 1/2. So each one of those is going to give me basically 2 answers. So I'm going to have 4 answers for this problem. Okay, first of all, my reference angle. Right, sine of what is 1/2? Well, isn't it pi over 6? That's real helpful, because then when I draw it for this guy, isn't sine positive here and here? And isn't sine negative here and here? So for this guy here, it's pi over 6, pi minus pi over 6, or 5 pi over 6. For the negative, it's pi plus pi over 6, or 7 pi over 6. And this is 2 pi minus pi over 6, or 11 pi over 6. So those are my answers, math fans. Theta is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, it's not too bad. Just don't forget the plus and minus. All right, let's try another quadratic. We're going to have sine of x minus 1 and sine of x plus 1. All right, so kind of look at this problem. Well, I got 2 different parts here, and how many answers am I going to have? Well, do you guys agree I'm going to have 4 answers? I don't know. Maybe not. Well, let's do. We got sine of x equals 1, right? Setting that equal to 0, and sine of x equals negative 1. Well, how many places does sine of x equal 1? It actually only equals it in one spot between 0 and 2 pi. So sine of what is 1? You guys should know that. It's pi over 2. Sine of what is negative 1? X equals 3 pi over 2. Okay, again, you guys should know that. You can always draw a picture or whatever, all your quadrantals, and figure things out by x, y, and r if you needed to, but really you should know those. All right, so truly there are only 2 answers for this problem, and I want to kind of explain why. If I'm graphing this, so negative 1 and 1, do you guys agree that my graph looks something like this, and like this, and like that? All right, so do you guys agree that I only hits 1 in one spot here, as opposed to all the other problems before? It hits like 0.9 2 times. It hits 0.5 or 1/2 2 times. Same thing here. It hits negative 1/2 twice, but it only hits negative 1 one time. That's like the lowest value. And how many times does it hit 0? Well, don't you agree it hits it here and here? Well, some of you guys are saying, well, what about right here? Isn't that one of the points? Well, no, because remember, it doesn't include 2 pi. So that's why I only have 2 spots where it hits 0. There's never more than 2, and and when it's one of the quadrantals as the maximum or minimum, then it's only one place that it hits. All right. Okay, so let's try another problem here. Sine squared of x minus 1 equals 0. Well, I know a lot of you guys are going, well, wait a second, Mr. Curvis. this is the exact same problem as before. Yeah, it is. I could factor it if I wanted and get the same answer, or I can solve for sine squared. So I get sine squared of x equals 1 square root. So sine of x equals plus or minus 1. So sine of x equals 1, sine of x equals negative 1. And then again, this is just the same thing. X equals pi over 2, and x equals 3 pi over 2. Okay, same thing. All right, so let's do a nice little friendly problem here. This is another quadratic. If I do sine squared of x equals 2 sine of x minus 1. Well, you guys need to recognize this is really a problem just like this. This is really x squared equals 2x minus 1. That's exactly what that looks like. This is just it's a quadratic. It's a factoring problem. So it's like moving the 2x over and the 1 over, and I get x squared minus 2x plus 1 equals 0. And then if I factor that, I get x minus 1 equals 0, so x equals 1. And then I go from there. Well, this is exactly the same thing, except I have signs. So I'm going to subtract 2 sine of x and add 1 to all sides. So I get sine squared of x minus 2 sine of x plus 1 equals 0. And this is going to factor as sine of x, and minus 1, and minus 1. So I don't need to set both of them equal to 0 because there's going to be the same thing. So I'm going to get sine of x minus 1 equals 0. So sine of x equals 1. And of course I only have one answer. It's only at pi over 2. Okay, that's not too bad. Let's try another one here. This is another, this is a good problem. This is sine to the fourth of x. So this is a quartic, okay, degree 4. Sine to the fourth of x equals sine squared of x. Now, I know some of you guys want to just divide both sides by sine squared of x. Well, math fans, you can't just do that because you lose roots if you just divide stuff out. You have to factor. It's kind of like saying x squared equals x. You can't just divide. If I just divide everything by x, I get x equals 1, and that's my answer. Well, don't you guys agree x also equals 0? Because 0 squared equals 0. That's true. So I lost a root if I do that. So that's like really bad to divide there. But you can factor. So what I want to do is I want to move the sine squared x over. So I get sine to the fourth of x minus sine squared of x equals 0. So I'm going to factor out a sine squared of x. And I get sine squared of x minus 1 equals 0. So don't you guys agree sine squared of x equals 0? So sine of x equals 0. Well, where does it equal to 0? Doesn't x equal 0 and pi? Okay, you guys should know that, right? Because it's sine of 0 is 0 and sine of pi is 0. And then, of course, I have this one. This is like our problem we did before. Sine of x equals 1. Sorry, sine squared of x equals 1, and take the square root of both sides. So sine of x equals plus or minus 1. So where does it equal 1? At pi over 2. Where does it equal to negative 1? At 3 pi over 2. So those are my 4 answers to that problem. 0 pi, pi over 2, and 3 pi over 2. All right, this next one, math fans, is just a little tricky because we kind of combine some sines and cosines. So this is using identities. All right, cosine of 2x plus sine of x equals 0. All right, so you can't mix sines and cosines together in a problem, all right, when you're trying to solve. It's like mixing cats and dogs together. It's very sad, doesn't work. The cat gets all grouchy and the dog bites the cat. It's a bad thing, okay? You can't mix cosines and sines. So what I want to do is I want to get try to get everything in terms of either all cosines or all sines. Now, if you look at this, I have cosine of 2x. Isn't that a double angle? In fact, I could write cosine of 2x as cosine squared of x minus sine squared of x, or 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. Well, think about it, math fans. I already have a sine of x here, so why don't I write that as 1 minus 2 sine squared of x. Now I'll have everything in terms of sine of x. All right, so it's a quadratic, and what I want to do is I want to have a leading coefficient that's positive and put it in descending order. So what I'm going to do is I'm going to divide everything. I could move everything over. I can divide everything by -1, however you want to do it, but I wind up with 2 sine squared of x minus sine of x minus 1 equals 0. And this is just like saying 2x squared minus x minus 1 equals 0. So that baby factors to 2x and x, and this is minus 1, and this is plus 1. And I believe that gives you the correct middle term, right? Negative x. So here we go. This is going to be 2 sine of x plus 1, and this is going to be sine of x minus 1. That's what that factors to. So I get 2 sine of x equals -1, so sine of x equals -1/2, and sine of x equals 1. So this is going to be 2 answers, because don't you guys agree sine is negative here and here, and my reference angle is sine of what is 1/2? It's pi over 6. So that means this third quadrant is going to be pi plus pi over 6, which is 7 pi over 6. And 2 pi minus pi over 6, or 11 pi over 6. And then, of course, sine of x equals 1. It occurs at pi over 2. So those are my 3 answers: 7 pi over 6, 11 pi over 6, and pi over 2. Okay, it's not too bad. Let's do one last problem here. What if I give you guys the secant of x equals -1/2? Well, so you guys are like, these are really difficult. Secants and cosecants are kind of challenging. Well, don't you guys agree that this is just a ratio? I can turn this into cosine of x equals the reciprocal of that, so -2. Right? That makes sense? Because secant is r over x, so this is x over r. And then we need to say, okay, the cosine of what is -2? Well, we can't quite do that, right? There's no value that's -2. In fact, if you remember that, it's x over r, so isn't that -2 over 1? And x can't be bigger than r. I mean, I know it's negative, but if we just cross off the negative, just ignore that. That can't be bigger. That always has to be smaller. So the deal with this problem is it's no solution, because it's impossible. So just remember, math fans, with sine and cosine, those values, the domain, has to be between -1 and 1. If it's not, you can't do it. You can't say inverse cosine or of cosine of 5, because there is nothing at 5. The maximum value is 1, the minimum is -1. Same thing if I gave you a secant and a cosecant problem. Okay, that domain, I mean, you flip it around to change it to a cosine problem to help you look at it, but that domain is, this is going to be a parenthesis here, is -infinity to -1, union, oops, that's a bracket here, union 1 to infinity. Okay, if it's not one of those values, then it's no solution. So that's really important to understand that kind of problem. Okay, don't just get pulled in and say, oh, geez, I got to find an answer. If it's not in the domain, you can't find the answer. All right. Anyway, that's it, math fans, for solving trig equations. We're definitely going to get to more complicated ones, but these are just the basic ones to get you guys used to, kind of looking to see what the angle is and given the ratio. All right, that's it, math fans. Have an awesome day. Adios. Goodbye.